So this is number 10, and this is one of the questions in this mixed practice review that I wanted to go over specifically for this one because there appears to be an issue with the way that it's keyed. And so I want you to see how to correctly solve this problem. Of course, I'm going to solve it with the numbers in my question, but you have different numbers in yours. So it's just the process that you're going to be looking at, and you'll want to repeat that with the numbers that you have on yours. So the question says, a student pushes a 15.5 kilogram lawnmower. The handle makes a 30.6 degree angle with the ground as shown by the picture below. Consider the rightward direction to be positive. So you've got some information here, but this one does involve an angle, and so you are going to have to find components. Remember, if you have an angle, the first thing you're going to want to do, or one of the first things you're going to want to do, is figure out how to find components. Now in this case, you don't actually know what the applied force is right now, so you can't find those components yet. But it is a process where you are going to have to use trigonometry whenever you get to that part of the question. Now the actual question that's being asked did not match the value that he asked for over to the side, so I went ahead and changed mine. I highlighted it yellow. On your copy it says F net, but if you read the question says if the magnitude of the frictional force is 10.52 newtons, what magnitude of force must the student apply to the lawnmower to accelerate at 1.55 meters per second squared to the left? And so the question's asking for the force the student applies, not the net force. So that's what I'm going to show you how to do, even though the label is different. So what we're going to do is I'm going to switch over to my document camera so that we can actually work this out. Okay, so let's go ahead and do that, and then we'll look at the second part in just a second. So this is information that was given in my question. Again, you have different numbers in yours, but this is my force being applied to push the lawnmower. This is the angle, 30.6 degrees. I have the mass labeled, if I can get this to focus, but I have the mass labeled, I have the force of friction labeled, I have the acceleration labeled, and what we're looking for is the force that the student applies. So I actually want to know what this is right here. And so there are several steps in order to actually solve this problem based on the information we have. But the first thing is finding the net force. So if you answered the question as it was typed, and it said F net equals, and you solved that, that's the first step of this process. But I'm going to go ahead and I'm going to solve for the actual applied force because that was the intention of the question. He just typed it wrong. So let's go ahead and do that. I can solve for my net force using the equation F net equals ma, where we have a mass of 15.5 kilograms and an acceleration of 1.55 meters per second squared to the left. I did go ahead and tack a negative sign on to indicate that this was in the leftward direction. So I'm going to multiply 15.5 by negative 1.55, and that is going to give me a net force that is equal to negative 24.025 newtons. All right, so again, this is not where I'm going to stop in this problem. I'm going to actually solve what the question initially asked for, what is the force the student uses. The student, again, is pushing this lawnmower at an angle. But now I have a net force, and what I really need to do is draw a free body diagram so I can see all of the other forces, and we could have done this step first if we wanted to. So I know that when the student applies this force to the lawnmower, because of the way that it was drawn in the diagram and the way that I drew it on my paper, I know that this is going to have a downward component and a leftward component. So I'm going to draw those components. I'm going to call this one Fy because it's in the y direction. I'm going to call this one Fx. But those are the components of this applied force that we're going to be looking for. If you want to draw the applied force on here instead.
Good afternoon, please pardon this interruption.
All right, so again, I have my components here. And when you have something at an angle, you're going to want to draw those. You could draw the diagonal one and then draw the components on it, but I think the diagram looks more clean if I don't include the angle. I can work out the triangle part over here, but I'm going to just draw the components over here. You don't have to do that, it's your preference, but I think this makes it easier to solve as well. Other forces that are going to be acting, I always need to include FG. So I have two forces that are both downward and vertical right here. And I need to include FN because I know that this lawnmower is being pushed across the lawn or a surface, the ground. And I know that the magnitude of FN needs to be equal to the magnitude of these two together. And so that's helpful because this lawnmower is not experiencing any vertical acceleration. I do need vertical balanced forces. Again, the lawnmower is being pushed to the left. And so the friction that's given here, this 10.25, is going to be a rightward force. And I'll go ahead and label it force of friction 10.25 newtons. So I've got a start. And I also have a net force. I could do this in a bunch of different orders, but ultimately, if I want to find this, I have to be able to find either this or this component here of this angled force. And so the one that I'm going to focus on, because it's the only one I really have enough information for, is this X component right here. So we're going to solve for Fx, and the reason I say that I have enough information for that is because I know that my net force is going to be acting to the left, because although they're pushing the lawnmower like this down and to the left,
Students and teachers, it is 2:50, which means that all students should...
All right, so again, I know that my net force is going to be to the left because this lawnmower is not accelerating vertically. Again, I said already that this is going to be equal to the sum of those, which is not enough information. So what I'm going to focus on instead is the horizontal, because I know the net force, and this net force is going to be to the left, and I know that because my acceleration in the question it said was to the left. They're always in the same direction. And so this net force is equal to the sum of my horizontal forces, which means I can write an equation that F net, or negative 24.025, is equal to the sum of my forces. That's Fx, that's the one I don't know, plus Ff. Now in this case, Ff is not negative because Ff is going to the right. So please just be careful with your signs. This is negative, but this one's not going to be. 10.25, and then if I want to solve for FF, I'm going to subtract that 10.25 from both sides, giving me negative 24.015 minus 10.25, which is going to be a horizontal component that is equal to negative 34.275 newtons. So that's helpful. That is not the answer, by the way, to the question, because this is not the total force from the student. It is only this component. I'm going to redraw this triangle down here so that we have more space to actually write. But we're going to have our component, or rather our applied force. Again, this is what we're solving for right here. And we know that this component of it, this horizontal piece of it, is what we just found, 34.275 newtons. Again, it's negative because it's to the left. If you want to add the negative on, you can. And I know this angle is 30.6 degrees. So with that information, because I know both the angle and one of the sides, I can use trig. I can use SOHCAHTOA to help me find this. Again, I'm looking for that one, which is the hypotenuse. So if I'm using SOHCAHTOA, then I have the adjacent side, and I'm looking for the hypotenuse. Adjacent hypotenuse, that's right there. That means we're going to be using cosine. And so we're going to say that the cosine of 30.6 degrees is equal to the adjacent side, that's this one, 34.275, over my hypotenuse, which is going to be the applied force from the student. You can label it whatever variable you want, but because it is applied, I'm going to go ahead and just use FA. Again, I can't solve for this algebraically when it's in the denominator. So the first thing I'm going to do is I'm going to multiply both sides by FA so that this cancels, and that leaves me with FA times cosine 30.6 equals 34.275. And from here, we're going to divide both sides by cosine 30.6. And we're doing that so that we can isolate our variable and have that all by itself. And so this is what you end up with is FA equals 34.275 divided by cosine 30.6. And if you put that in the calculator, that's going to give you the answer. Now you'll notice I don't have my signs on this. I didn't label it with a negative, even though it was negative up there. I'm just looking for the magnitude. I can worry about the direction in a minute. But when you do this calculation, you do want to make sure that you are in degree mode. So on the TI Inspire, that means you need to check up here at the top by the battery indicator and look for those letters D, E, G. So if I want to take my answer, 34.275 and divide it by cosine. Again, if you're using trig on this, there's a button right here next to the 7 that says trig, and then you can arrow over and choose cosine. Go back down. Divided by cosine of 30.6. And then this is what you're going to get, 39.82. It's rounded, but that's close enough because there's a 0 after it. 39.82. If I want to write more, I could. 8203. We'll round it there. Okay, but that is the applied force at the angle right here, and that would be the answer to the question for the student's applied force. So if I go back here, what I don't think this is actually keyed right. Whenever I checked it earlier, unless I made a mistake earlier. 8203. Yeah, it's not. I can see the red right there. So it isn't keyed right, and the net force isn't keyed in here either. He has something wrong with the math, but that's how you get that applied force and the net force along the way. Let's answer the follow-up question. The follow-up question says, if the length of the yard is 24.5 meters, and the lawnmower is initially at rest, how long will it take the lawnmower to accelerate the length of the yard? When they start giving you distances and times and ask for how long it will take or ask for a velocity, then you know you're going to be looking at those kinematic equations. So I'm just going to label everything. I have a distance given to me as 24.5 meters. I have an initial velocity given to me as 0 meters per second because it's initially at rest, and we're looking for a time. And so I'm going to go back to my document camera and take a look. Okay, so we have this here. Now, the original question did provide us also with an acceleration, and it said that acceleration was negative 1.55 meters per second squared, or rather it said 1.55 meters per second squared to the left. So that does mean that the displacement of the lawnmower will be to the left. I do want to add that on there because if we're pushing it to the left, it's going to go left. And again, the picture shows that as well. If you have one of those signs wrong, you're going to end up with a negative time. So you're going to realize something went wrong because you can't have a negative time. All right, with the information we have, the kinematic equation that makes the most sense is this one, delta x equals VIT plus 1/2 AT squared. And so if we substitute in, that's going to be negative 24.5 equals 0 t, that's going to go away, plus 1/2 times negative 1.55 times t squared. From here, we can do this in whatever order. We can just move these separately, or I'm going to go ahead and just get what half of negative 1.55 is, which is negative 0.775, and I'm going to divide by it because it's being multiplied here, and I'm trying to get time by itself. So if I divide both sides by negative 0.775, then this will all cancel, leaving me t squared on this side, and on the other side I'll have negative 24.5 divided by that negative 0.775, and when we do that, we're going to get t squared equals 31.6129, and again we want just t, so we want to square root both sides. So again, The square root button, by the way, on the Inspire is right here. You have to use the control button and then the x squared, and then it'll pop up. Square root of, and again, you can arrow up and press enter, and it'll pull that number down so you don't have to retype it. But square root of that is going to give us a time that is equal to 5.62 seconds if I round it. And so that would be the answer that I would put, 5.62 seconds. Again, I don't think this is going to work because I'm pretty sure it's keyed wrong the whole way through. I don't even see anything popping up. Oh, that one did work. Okay, so that one actually counted mine correct. But this one did not, so just a heads up. All right, but again, there is an issue with number 10 right here. It is asking for net force right here, but in the question it's asking for applied force. I switched mine so that it asks for applied because that's the trickier one to do. Again, some of these do have issues with the negative sign. If you're typing in an answer that's supposed to be positive and you're not getting it correct, it's probably because it's incorrect. But again, this one did have a typo. Right now I don't know of other ones that do. Hopefully it's just the one. But again, you shouldn't have to type a negative number in on any of them to get a right answer. So if you're having to do that, then you're probably not getting the right thing unless it's supposed to be negative. But again, on this particular question for the first part of number 10, it will actually count any negative value correct. So even though we tried the actual answer earlier, which was 39.8203, if I try negative 39.8203, it will count it right, or it should. I may have already fixed this one. So anyway, but that's what you need to do for number 10.